Okay, so we are recording. Right, let's go. अरे यार ये बाल कभी भी ठीक नहीं रहते. कुछ दिख ही नहीं रहा. कि चश्मा भी पहनना पड़ेगा. Right, let's go. Okay, so I was studying this for today's task, but let's start with this. And okay, so for today so I'm back. Jai Shri Ram sabhi ko. Jai Shri Ram. And I am getting 58 FPS. Why? I should get a 60 FPS, bro. What is output? And high CPU usage, high quality. Apply, okay. I think we have available CPU to use that, bro. Okay, it does not work. Stream, appearance, output. Let's do ultra fast, low CPU usage, lowest quality. No, we don't know that. Don't want that. Video is okay. Appearance, general, apply. Okay, it's fine. We'll just I've done with my skincare and let's start. Okay, so for today's for day 4, right, I did was what did I do for day 4? I did that day 5, like, okay, school, search, charging this device by USB. Okay, it's cool. Okay, for day 4 I did the final question that yeah, this was the research I had to do. Cool. So let's go back. Search and rotated sorted array I did for day 4, right? Okay, so in this question, right, so we are given with, please sit here. So Mr. Pengu is creating some problems for me. Please sit here. Yeah, you're a nice guy. And okay, so there was an integer array nums sorted in an ascending order, that non-decreasing order. It's a same thing, bro. So with distinct values, so we are given with distinct values. That's a plus to be written, like screen capture. I would have to do this every time for SCR. Source copy, audio input is set to hello, cool. And video capture device. Oh, okay, right. It's fine like that, right? Okay, so let's go to page number 5. Do this and SCR. Yep, we get the SCR CPY. Right, let's go. Window F, or I can do this. I can keep it here also, right? Send to page number 4. Okay, yeah, I can also do this if I want to, right? So let's not look at the code and just check out. Okay, it has to okay. So my own okay. So my own image is it lagging? I think it is lagging a bit. Uh, hello. I think it should go to the page 4 only. Right, so let's open the pad again. This was the binary search code that I tried. Right, so oh, there's the code that I have already written for this. So search in a rotated sorted array. Right. So so for this, right, okay, so we were given with the okay, cool. So I will just take this for the time being to the page number 4. Right, so it's here. Right, okay, so let's take the elements and then move on to the page. Right, so there's an integer array nums sorted in an ascending order. Right, so it's ascending order, and we have nums array, right? So nums array, cool, with distinct values. Okay, so we are given distinct values. Prior to being passed to your function, the nums is probably left rotated at an unknown index k. 1 is less than equal to k, which is less than nums dot length. So I believe the voice is out of sync. Let me check. Ascending order, right? So ascending order, and we have nums array. Right? I believe it's fine. Yeah. Let's just pause this. Yeah, go back. Let's just go back to this. I believe it's fine. Yeah. And keep this at page number 5. Yeah, that increased the frame rates. Right. So full screen, and okay, so we get the distinct values such that the resulting array is this, right? It's a zero indexed array, so zero indexed. Cool. For example, this might be left rotated by 3 indices and become this. Okay, cool. Given the array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1. Okay, so return -1 default. You must write an algorithm with O log n complexity, time complexity with O log n. Time complexity O log n, which obviously is binary search. So it's binary search. Everyone knows that. Cool. So nothing new. Okay. So let's take an example and then go to back to the tablet. Okay, so this is an example. So nums is equal to 4 5 6 7 0 1 2 and target is 0. Okay, so no switching back and forth now. Okay, so first of all I would in an interview or something like that, I would really try with the brute force solution, something like brute force solution. A brute force solution for this can be what? Linear search. Everyone knows that. So linear search. Cool. And how would linear search would go with this? So let's take this, right? And let's take a I value. I. Cool. And 3 4 5 and 6, these are the indexes. Cool. And we take a I variable like this. Cool. So this, what would happen, it will be like the first index I equal to 0. Are you the target? No, I'm not. Are you the target? And no, I'm not. Then are you the target? And no, I'm not. Are you the target? No, I'm not. Are you the target? Yes, I am the target. So it will be like, then if we found the target, we can return instantly, return I. Or if we don't find the target, if this thing passes the array, then by default we get the return -1. So it's a linear search approach, right? With the time complexity would be like something like big O of n. When the iterator I goes to the, but if for it to be the big O of n, the target has to be, can be like 2. So at the last position we will find the value. Cool. Okay, but if you want, I can write pseudocode very quickly, and also the space complexity would be O of 1, because we are just using some variables and nothing more. Cool. So let's just erase this and go back to the better approach, right? So what would be the better approach? So here is time complexity big O of n, and space complexity is nothing, constant space. But better approach would be obviously this. So binary search, right? How would we apply the binary search to this question is the actual thinking process that we have to think about. So thinking process that we have to think about. Wow. Okay. So how can you approach this in interview? So I will be like, I can see that it is a sorted array. Okay. And we have to search something, right? So binary search, right? Binary search always comes with the big O, log, any base like 2 majorly, and complexity, and space complexity is always O of 1 for this case, not for every case, but for this case. Cool. Okay, so let's talk how the binary search would work. Let me adjust. Okay, so how would binary search will work in this case? It will be like, okay, so how would binary searching work in this case? I have no idea. Let's just talk about it. Cool. So let's take a new page. Cool. Oh, okay. So this is the DSA grind chapter. Like, we can take the, I have to select a pen. Nums equal to 4, 5, 6, 7, 0, 1 and 2. So we can take a variable low and a high. Okay, cool. Let me write the indexes real quick. 0, 1, 2, 3, 4 and a 5. Cool. These are the indexes. What is your problem, bro? Oh my. Come on, bro. Come on. Let's not do that. Index. What is this guy's problem? I have no idea. Nebo, if you're seeing this video, please fix this. Index. Cool. So let's do this. So we have to always calculate a mid, and we will be using the low plus that overflow formula. So high minus low divided by 2. Okay, that's cool. Yeah, cool. Okay, so let's take this out of here. Okay, if it is that, so 0 plus 6 by 2. If you're wondering how this can overflow with, like, so integer basically has ranges from minus 2 into 10 ki power 9 to 2 into 10 ki power 9. So what if low is at the position 1.5 to the 10 to the power 9? What happens? It can happen, yeah. And high is at the position something like 2 into 10 to the power 9, right? So I'm explaining how this would not overflow for the int, right? So sorry for that, right? So it would be like, so if we apply this formula, so low plus high by 2, and it will be like 1.5 plus 2 to the power 10 to the power 9, and this is 3.5 into 10 to the power 9. Let me change the pen for explaining. And orange. Okay, so if you see that 3.5 into 10 to the power 9 divided by 2, so this already overflowed, right? It would be a negative something very big number, right? Because integer max has only this range. Cool. Already overflown by that. And even if we try to 1.5 that, we first have to do this. And obviously it would be an integer division, because both of this is an int and this is an int, right? So that would happen, and it would be overflown. So it would be a negative very big number. I have no idea what that be, but it would be a very, very big negative number. Cool. Okay, so that's that. And how this formula prevents it, it's like if it is low, which is 1.5 into 10 to the power 9, plus then it is high. High was 2 minus 1.5 into 10 to the power 9, which is divided by 2. So 1.5 into 10 to the power 9 plus like 2 minus 0.5 into 10 to the power 9. Cool. And again divide by 2. So even if after dividing by this 2, this will be inside an integer, and this will be also inside an integer, and there will be no overflow cases here. So it's cool, and everybody should do that always, right? So let's just go back to the question now, right? We had to calculate mid, which was so 0 plus low plus high, low plus high minus low divided by 2. Cool. And we can do mid equals to 0 plus 6 by We can do this for very small variables. It is no problem. So this will come out to be 3. So let's put a mid at 3. Here's the mid pointer. Cool. Now the real logic comes here. Okay. So what would happen? So first of all, we would compare it with our target. So target was, I believe this, I should use a light color. So target was 0. Cool. So we would compare it with the like while low less than equal to I, standard binary search, right? And we calculated mid equals to low plus high minus low by 2. And if what happens, the nums at the position mid, right, it is, what if it is greater than the target? Cool. If it is okay, so first case would be if nums at the position mid equal to target, then we would immediately return mid. Okay. And nums, if that does not happen, right, then this case will come true, true or false in that case. So what if happens if nums mid is less than equal to target, less than target? So actually it is greater than target, but we have to like less than target. I don't think that I did that. I matched the case where it was with okay. So you can do any case if it is greater than target, right? It is greater than target, right? So what would we do? We have to check that if this, like it is mid. Cool. So mid is actually lower, greater than or not. So nums at the position low, right? At the position low, we have to find we have to check what part of the, it's a sorted rotated array. So there will be a part which will be sorted every time. So we have to check that. Okay. If nums at the position low, that is this one, right? If that is what it is, right? If our, okay, अबे यार सृष्टि की याद आ गई. Okay, back to trauma bonding नहीं करनी भाई. Okay, back to the question. If the target value is inside this range, right? This range, it is not, but if it is, let's just do that, the case where it actually makes sense, right? If it is greater than target, then something would happen. If it is not, right, then what would happen? So obviously the else case will run here. Okay. And it is not, then we have to check, we have to go to this position, right? Okay. So let's go there. Okay. We will check, right? We will check if the target is in between mid and high. We have to check that. So we will check nums at the position mid, right? Okay. Should be I was doing it wrong, bro. Okay, I forgot it in one day, right? Let's just go back to what happened. Okay, so in that case, the nums mid was less than target. No, it is not. We have to check for this first. So this. So if it is less than nums, what do we say? Nums mid is equals to nums at the position. Oh, okay, that's we have to check if the sorted array is at the position left than the mid, right? So nums at the position low should be less than or equal to nums at the position mid. If it is, then this case will run, okay, and if it is not, then another case would run. Let's first talk about this case. So let's make some space. You go here and we'll call this here. Okay, if this happens, right, then we have to again check if the okay, so first we checked that if low is less than or equal to medium. Cool. Okay, we have to check that if the right part was sorted or not. Okay, cool. Because if it weren't for that, right, so if nums low would have been greater than nums mid, then it would not have not been sorted. The right part of that array would have been sorted. Okay, so now we will check if our target is in between low and mid. So let's check. So our target should be greater than or equal to, right, nums at the position low, right, and it should be target should be, right, less than what? It cannot be equal because here's the equal case, right? Okay, I have not collected the Bluetooth. Lol. Oh my god. Yeah, suction span is connected. Good. And if target is less than nums at the position mid. If that happens, which is the case, I need more writing space first. Oh my god, this. Right, let's shift here. Yeah, to the max. If that happens, right, congratulations. That is actually the case here, right? Then what we can do is we'll just oh, okay, that is not the case here, right? So let's focus on else part first. If the target is not between this, okay, so it is not between that, then it should be probably be between mid and high. Okay, so we will move low to mid plus 1th position. Okay, that's easy. Yeah, and if it is not, if it is inside that, then we will move high to mid minus 1th position. Cool. That's the if part. If that part is, if this part is sorted, whatever this part is not sorted, right, then it would move to here, else case, right? Again, we will compare the target. If the target, right, has to be greater than or equal to, now this time this has to be here, so it has to be greater than or equal to nums mid, right, and the target has to be smaller than, it has to be greater than, only strictly greater than, and it has to be less than equal to nums at the position high. If it is if that is true, then obviously the low will move to mid plus 1, else right high would move to mid minus 1th position, right, like that. Okay, and if at the end of the day the mid is not there, then we can, if at the end of the day this loop has not run, right, then this return minus 1 will run. So that was the question I did. Else high is equals to mid minus 1 and everything is here. Let's run it and submit it. Yeah, let's go. I never get how this we are seeing that, right? Okay, I will submit again. This person will jump here. Yeah, now you are not going to do that. Yeah. Okay, so this was the question I did, and this question that I was tried, find first and the last position of an element in sorted array. I believe that I showed this question, right? Okay, and also which question I did? Search insert position. Okay, also this I was learning. So okay, so iterating through a standard vector is 100 times faster than a standard list. Wow, that's insane. That's cool. Okay, and we will talk about it tomorrow because that I have to do today. And okay, so prep reality check these questions. Okay, search insert position. Fine. If you'd like, I would love to explain Coco eating bananas because I that is the only question that I loved to do, and I would love to do it again, right? Or should I start with the revision of the stuff? I don't know, man. Come on. Okay, and about post increment and pre increment, that was a cool thing to do. Cool. So yeah. Also, let's just search insert position. Why is iterating through? We will do this later. And okay, let's. Oh, okay. The tablet is switched off. Huh? What's this? F. Huh? Let's just go over to Sublime Text. Okay, also I was setting up my VS Codium here with the things I downloaded from my company laptop. Also, I did a lot of company grinding stuff. I don't think I can show that. I don't know if I can show that. Okay, this was the HFT things I was doing. So, and I have VS Code Pokemon here. What Pokemon is that? It's a Henry default Bulbasaur. Yeah, let's go, man. Bulbasaur. And this is Akita dog. Hey, who are you, man? Tramp. Yeah, this get lost. I would love to get a dog. Akita. And I will name it as Ganga. I had a dog. A very, 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 very loyal one. Right? The most loyalest creature that I can ever get. That was my Gange. I will give that Ganga. Yeah, there he is. Okay, so I believe the things that I brought. Okay, so this is doing numbers to the frame rate, right? Are we good? Yeah, we are better now. Okay, let's just restart the extensions. Okay, so cool. And let's write some code, and I want you to be with me until I am writing. So IO stream is what I will include, right? And Let's talk about vector.reserve. Okay, so this is the concept that I learned and I would like to share it with you. Let's assume you want to have okay. What happens is that okay, when you are creating a project, right, in a C++, so what happens is that if you use a vector, we everyone knows that vector is what, like, it's a dynamic array. Okay, so how does it become dynamic, right? It actually it's actually what happens is, right, okay, I'll explain that to you, right? And yeah, my laptop tablet makes that sound. It likes to do that. I'll just create a notebook, yeah. New notebook, or new document. Let's do a document. Uh, Try writing smaller characters. What the? Yeah, just get lost, man. New document, new board. What would happen if I so content? By the way, you can write with pen also in this. So new board, and I'm trying to write it with pen, bro. Come on. What is your problem? When I want to write with pen, it does not let me write with pen. When I don't want to write with pen, it wants me to write with the pen. Wow. So amazing technology, Motorola. Oh my god, that's cool. Okay, it's an infinite board type. Yeah. So what happens is when we define a vector, right? Vector, that's okay. We have to give it a data type and v. Okay. So it does not have any size at the starting of this. So imagine it's like a it's and v dot size is 0 here. Okay, and we push back something to it. Push at the back. Let's insert 1. Okay, it will initialize a vector, like it will be like this, and it does 1. Okay, and it has a address something like 0x or blah 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 blah. V dot size becomes 1. Okay, if we push back, right, 2. Okay, now it becomes a bigger vector. V dot size increments, and it it actually moves that data. So 1 was there, it has to move that data to this position. So it had some address 0x1. Now this is a new vector. Okay, so it has to move that projection. uh, let's assume address is always x, so x here becomes 0x2, and this becomes 0x2 plus 4, it's like 6, right, and this becomes 1, then 2. So it actually moves the data that you feed to it. So like here the 2 will okay, so you got my vibe, right? Okay, again v dot push at the back. Okay, so 3. Now again a new vector will be created, right? 1 2 3, and now this will have 0x3. This data was copied here, and in HFTs or like low latency systems or something, very doing a market research, or these bigger machines that do like nanoseconds of micro calculations, they cannot afford this, because copying, right, copying is expensive. It is very expensive, and so right, okay, and v dot size, can you guess what it becomes? 4. If we do a v dot pushback, like 5, then nothing will matter here, it will not change, right? But as soon as I do v dot push back 6, it goes out of this, right? And it becomes now 5 into 2, which is 10. Vector doubling, this is called, I believe this. So what's the optimization here for HFTs or something like that? We can, what I thought optimization could be, I actually wrote that vector int, be with me, v and 10. I wrote this, this I wrote. Poof. This is wrong. If you cannot figure it out, this is wrong, completely wrong. Because what would happen? It would create a 10 size vector, right? Assume this is a 10 size vector. Good. And then if I do v dot pushback, and it would create another place. It would become 10 into 2, 20 size vector, and then it would push 1 in that position. So also not in that this vector, if it had 0x1, this all vector will have 0x2, because you have to copy the contents also. So that was my mistake, right? What we should actually do, what C++ and HFT devs and everyone wants to see, is a very, very easy thing. Like, I will change the color so that it's a very, like, most stupidest thing that ever. So v dot reserve, and any size. If you want 10, you can get 10. Boom. It would create empty spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. And now if we push back here, 1, 2, 3, 5 and 6. Okay. And it will have same values, 0x1, 0x2, and no copying, right? No copying. Okay. And they can always use storage, man. Using storage is not an issue, right? We can always use storage, but this makes the always also the pushback operations are O1, so no issues with that. But this was the thing, bro. I thought for like 30-35 minutes on this same thing, and this was the solutions. This v dot reserve. I totally get that, but it was very stupid, and I laughed at myself. So I think I will stop here now, and okay, then bye. Yeah, bye, I guess. Okay, Pengu, Mr. Pengu, say bye. Bye, folks. Okay, bye. Jai Shri Ram. Keep learning.